All right, here's an interesting exercise, and then the second part is a little trickier than you'd initially think, but they got a proof. I'm not sure if it's the best proof, but it is a proof. So let's start with the first part. So if AB equals 1 and CA equals 1, then let's see here, if you were to multiply that second equation by, no, the first equation by C and flip it, you'd get C equals cab, but AB equals 1, so this is just, oh wait, no. CA equals 1, and so this is just B. So AB equals 1, which is also equal to BA, because that's, well, here, so this is CA, which is equal to BA. So AB equals 1 equals BA means precisely that A inverse equals B well, no. I don't need to say like A is invertible in M with inverse B. I'm just going to write A inverse equals B to mean that A inverse exists and it is B. Okay, so for the next part, as usual, one direction is easier than the other, which you would expect, because the probability of two, if you assume that difficulty is a continuum, then the probability of two different problems having the exact same difficulty is 0, and so one is going to be more difficult than the other. But anyways, usually they're not too different in difficulty, except when they are. So then, if alpha inverse equals B, so A inverse equals B, i.e. if A is invertible and it has inverse B, then we have to verify those two things. So ABBA equals A inverse A, which is just A, because those two say will cancel, and AB squared A, that's just A inverse A, and the first two cancel, and the second two, and the last two cancel, and so this is just 1. If we assume ABBA equals A and ABBA equals 1, then now what you might be tempted to do is say like, oh, well, if you just multiply both sides of this by A inverse and you get BA equals 1, and then you just kind of go from there, but you can't do that because you don't know. You're not assuming anything about A and B being invertible. All you can use are these two equations. And so here what I was thinking was like, oh, so AB, so you can think of this AB times BA equals 1. So if BA times AB equals 1, then we would be able to invert at least AB. Or we would be able to invert these two elements. So it led me to this line of reasoning, which may not be the best just because there's going to be a lot of letters here, but it's not too bad, so it's fairly quick, so it might be easier than any other form of proof. So anyways, so BAB equals BABABA, which is just we added the ABBA at the end because it's 1, and that you condense this part here down and you get BABABA, which is just ba, because the last 4 cancel. And so 1, which is ABBA, which is just, let's see here, so 1 is ABBA, which is, you replace the final BA by BAB to get ABBAB, and then you cancel the first 4 to get AB, So 1 is, which is ABBA. But we know that the AB is 1, so this is BA. So what does this mean? So we know AB equals 1 equals BA. And so A inverse exists and it equals B. And there we go. This completes the proof.